Welcome all of you once again to the part 5 of data preprocessing. So let's move towards the goal of today's lecture. First of all, we will see what is feature scaling. Then we will see why do we need feature scaling. And in the last, we will see some feature scaling techniques. So let's try to understand that what is meant by feature scaling. One of the most crucial data preprocessing steps in data science before using machine learning algorithms is feature scaling. If the data is not scaled, algorithms that calculate the distance between the features are skewed or biased towards numerically bigger values. The magnitude of the feature has little effect on tree-based algorithms. Additionally, feature scaling promotes faster training and convergence of deep learning and machine learning algorithms. All independent features are brought into the same value range through the process of feature scaling, either 0 to 1 or -1 to 1. So let's see an example. Let's imagine, for instance, that we have the features x1 and x2. x1 has a range of 1 to 100, and x2 is between 10,000 and 1 lakh. All of the features values will be adjusted to the same level through the feature scaling, which is either -1 to 1 or 0 to 1. Now you might be thinking that why do we need feature scaling? Take the same values for x1, 1 to 100, and x2, 10,000 to 1 lakh. The result may have a considerable variance because of the variable range of values when features are scaled differently or when algorithms like k-nearest neighbor are used that heavily rely on distances. Feature scaling is necessary in these circumstances. Furthermore, we experience significant effects like computational complexity and sluggish convergence to the ideal values as a result of a wide variety of independent factors. Let's see the feature scaling techniques. The most widely used and simultaneously most confusing feature scaling methods used are below. The first one is normalization or min-max scaling. The second one is standardization. First of all, we will try to understand normalization or min-max scaling. The process of normalization involves moving or rescaling the data into a range, for instance, between -1 and 1, or between 0 and 1. The minimum and maximum values will be mapped to the numbers 0 and 1, respectively. The other numbers will be scaled based on this. So let's see an example of it. You can see a data frame having values 300, 400, and 500. The minimum value in the data frame is 300 and the maximum is 500. So 300, which is the minimum value, will be scaled to 0 and the maximum value will be scaled to -1 and the other values will be in between them. Now let's see how to do it. You can do normalization or min-max scaling by this formula. You have to subtract the minimum value from the x and then divide it with the value which is the result of the subtraction of maximum and minimum value. Now let's see what is standardization. Z-score normalization, or also known as standardization, is the transformation of features through mean subtraction and standard deviation division. In standardization, data are transformed by standardization so that the mean is 0 and the standard deviation is 1. Let's consider an example. The data frame here have the values 1, 2, and 3. So for the first value, the standardization value is minus 1.23. And for the second, it is 2. And for the last, it is 3. And here is the formula for finding out standardization, which is x minus mean divided by standard deviation. Now let's see a visual representation of normalization and standardization. As you can see here, it is the actual dataset, and these values are spread across the dataset. After normalization, the values or the data points are rescaled between 0 and 1. And after standardization, the values are rescaled at different positions. So let's see the difference between normalization and standardization, and you will know when to use which technique. So first of all, in normalization, we use minimum and maximum values for scaling. However, in standardization, we use mean and standard variation for scaling. Next, we can see that normalization is much affected by outliers, and standardization is less affected with the presence of outliers. Now, as you can see here that normalization is really useful when we don't know about the distribution. However, standardization is useful when the distribution of data points makes a Gaussian or a normal distribution. So this is the end of this outline. So far you have learned different techniques for transforming categorical variables and also how to encode and do scaling. Now good luck, see you next time.